Hey guys. All right, this is a video I promised you that kind of takes the place of Thursday, February 4th in class. So what we're going to do is we're going to review inverse trig in case you had trouble on that worksheet. And then we're going to move from that to exponential functions and logarithmic functions. Okay, so hopefully what I'm about to do is share a PowerPoint with you. All right, so let's see if it's going to work. On a good day. Yay, it's a good day. Okay, so what we're going to do is we're going to start reviewing that inverse trig like we talked about in class. All right, so I want you to look at something. All right, what happens is you have to decide what quadrants you're in first. So remember, what question one's asking you is what angle has its cosine to be a negative square root of 3 over 2? So my answers are going to be angles right here. All right. And when it's arc cosine, you have to determine which quadrants you're in. So you need to memorize. You've got it's either 1 and 2 or it's 1 and 4. So you really need one way to remember it is you need a positive and a negative quadrant. So think about cosine's positive in quadrant 1, but is cosine negative in quadrant 2 or quadrant 4? Quadrant 2. So quadrant 3 is never an option when it's got the word arc. Okay, so when it says arc cosine, you should write down the quadrants you're allowed to be in. So I'm allowed to be in 1 and 2. Then I try to decide which one of those it is, and I look at the SIGN. This cosine is negative. So is cosine negative in quadrant 1 or 2? Remember, cosine depends on x, and x is negative in quadrant 2. So I know that my angle is going to be a quadrant 2 angle. So that's how I decide what quadrant. I write down what quadrants I'm allowed to be in with arc cosine. If it's positive, it's quadrant 1. If it's negative, it's the other quadrant. Okay. Then I build the triangle that makes this true. Now think about what cosine is in words. Cosine is adjacent on top of hypotenuse. Okay. So I build a triangle. A right triangle, my adjacent side is the square root of 3, my hypotenuse is 2. So by the Pythagorean theorem, that's got to be a 1. So I go, oh my goodness, I recognize that's a 30, 60, 90 degree triangle. So how do I decide if this is 30 or 60? I look at what it's across from. All right, which angle's across from the 1, the 30 or the 60? We'll see it's the 30. But remember, our answers have to be in radians. So 30 degrees is 180 degrees divided by something. So you can use your calculator. If you divide 180 by 30, you get 6. So this right here has got to be a 6. So remember, 180 degrees is pi radians. So 30 degrees is the same thing as pi over 6. Now, why isn't pi over 6 my answer? Because remember, pi over 6, 30 degrees is in quadrant 1, and we agree we needed a quadrant 2 angle. So I need the quadrant 2 angle whose reference is 30 degrees. So remember, this is the little formula I put on the board for you. If you're in quadrant 2, your reference angle is 180 degrees minus your given angle. So I'm trying to find my given angle. So my reference was 30. So 180 minus, I just put a variable there because I didn't know it, and I just solved for x, and x came out to be 150. But remember, I can't put my answer in degrees. My answer's got to be in radians. So I had to change it. So luckily, this number is always going to be a multiple of your reference angle. So I try to decide, what do you multiply 30 by to get 150? And the answer is 5. If you don't see that, remember, you can take 150 and divide by 30. So it's 5 times 30, but then remember, 30 in radians is pi over 6. So I put pi over 6 in place of 30. So that's where I got 5 pi over 6 for my final answer. And I double check. That is a quadrant 2 angle. That's 150 degrees. Okay. Now, the whole top of your worksheet is worked like these. I give you the numerical, what you think of as the real number answer, and you tell me what angle that goes with. So the whole top of that worksheet should have angle answers. Now, the bottom of the worksheet was different. There was an additional trig word in front of this. So look what it means. It means this answer to this bracket is an angle. Find the sine of that angle. So that's why I'm getting real number answers, not angle measures. The answer to the bracket is an angle. but I didn't stop with that. I wanted the sine of that angle. So this is what we did back over here. If I've got arc cosine, I know that I'm in either quadrant 1 or I'm in quadrant 2. Remember, cosine depends on x. So where is x negative in 1 or 2? Well, it's in quadrant 2. So quadrant 1 is no longer an option. So the answer to this bracket is some angle in quadrant 2, but I don't even really have to find that angle. I just need the sine of that angle. Well, think about if it's positive or negative. Doesn't sine depend on y? So what's the SIGN of any y value in quadrant 2? Aren't all the y values positive? So that's how I knew to put a plus right here. That's where I got the plus, because the sine of any angle in quadrant 2 is positive. Now, how did I get the number part? I went back and built this triangle. Cosine is adjacent over hypotenuse. So I made my adjacent side the square root of 3 and my hypotenuse 2. Pythagorean theorem made that 1. Now let me remind you, don't ever put a negative on a length. Okay, a side can't have a negative length. So that negative is just telling me what quadrant. That's not the length of the side. Okay, so again, I can find that angle like I did back over here, but I don't even really have to find the angle. I just need the sine of that angle. And sine is opposite over hypotenuse. So that's why my answer is 1 over 2. So I could go figure out that that's 30 degrees, but I don't even have to do that if they just want the sine of that angle. Well, let's do another one. Arc secant. Now remember, secant's the reciprocal of cosine, so it follows cosine. So arc secant is defined in quadrants 1 and 2. So you got to know which trig functions are in 1 and 2 and which inverse trig functions are defined in 1 and 4, and write that down first. Now, do you see that it's saying some angle has its sign to be a positive square root of 2? So where is secant positive, in quadrant 1 or in quadrant 2? Well, secant's positive in quadrant 1, so that's how I know that the answer to this bracket is an angle in quadrant 1. So then I decide, what's the tangent of any angle in quadrant 1? Is it positive or negative? Well, tangent in quadrant 1 is positive, so that's how I knew to put a plus right there. How did I get the number answer? I built the triangle. Now remember, I really need a fraction, but I can put any number over 1. So remember what secant is. Secant is hypotenuse over adjacent. So the hypotenuse was a square root of 2, the adjacent was 1. I used Pythagorean theorem to get that number. So now I just need the tangent of this theta right here. Well, what's tangent? Tangent is opposite over adjacent, and 1 over 1 is where I got the 1 answer. Okay, so if it just has arc cosine or arc secant or something like that in front of a real number, you're going to get an angle answer. But when it has another trig word in front of all of that, I'm going to get a real number answer. Okay. All right, so let's get ready to kind of move to the next slide with a couple more examples. All right. Arctan. Okay. All right, so, okay. Let's see if I can move this down some. All right. All right, it's a little hard to see that problem with this thing, and I'm afraid if I undo it, it'll go away. So here's what it says. You can't really see the problem very well. It says cosecant. All right, and then in parentheses, a bracket, I've got this arctan. Okay, so arctan. It's hard to write with this cursor. That's just kind of sad, isn't it? Let's clear it. Okay, so right here, it says arctan. Okay. So I had to try to decide in what quadrants arctan was defined. And so again, I've got it memorized, and it's in quadrant either 1 or 4. So that's why I wrote down quadrants 1 or 4. Now next to it, it said that I had a negative square root of 3. Okay, so that's what's in that bracket that's a little hard to see up here. All right, so I've got arctan of a negative square root of 3. So where is tangent negative, in quadrant 1 or in quadrant 4? Well, it's negative in quadrant 4. So that's how I knew that I had a quadrant 4 answer. Now in front of this, it said cosecant. Now remember what cosecant is the reciprocal of. Cosecant is the reciprocal of y. So what is any y coordinate in quadrant 4? Do you understand that it's negative? So that's how I know that this final answer is going to be negative. All right, and then I build a triangle. So again, that's really over a 1, and tangent is opposite over adjacent. So I've got this angle right here, this theta, that I'm trying to figure out. So the tangent was opposite over adjacent. I used Pythagorean theorem to get a 2. Now, all I need on this same angle is I need the cosecant. Well, cosecant is going to be hypotenuse over opposite. So that's how I know that the number answer is going to be a 2 over a square root of 3. But remember, I'd already figured out that it was going to be negative. So that's why this answer is a negative 2 over the square root of 3. Now, sometimes they'll even have algebra, so you really aren't going to know the SIGNs because you're not sure what quadrant you're in. So arc cotangent, remember, is either in 1 or 2, but I can't tell by this sign which one it is. So I'm not going to have to worry about that right now. So cotangent, remember, is adjacent over opposite. So I built a triangle where the adjacent was x and the opposite was 4. I used Pythagorean theorem, leg squared plus a leg squared is my hypotenuse squared. So x squared plus 4 squared, 4 squared 16. I took the square root of both sides. So I either get a positive or negative square root of x squared plus 16. Well, a length can't be negative. Okay, so here's my triangle. Now remember, here's my angle. I need the cosine of that same angle, and cosine is adjacent over hypotenuse. So that's where I got that. So if I'm in quadrant 1, then that x would be positive, so I would get a positive answer. If I was in quadrant 2, that x value would be negative, and I would get a negative answer. Okay, so hopefully that will help clear up a little bit of maybe what was bothering you, previously. All right, on that worksheet. So if you had trouble with that worksheet, go back and redo it. All right. Now what we're going to start next, we're going to start first exponential functions. So I want to make sure that you understand the difference in something. And that is this. You're more accustomed to seeing variables raised to numbers like x squared or x cubed, x to the 1/2, letters, variables to numbers. Well, we're not going to do that right now. Instead, we're going to do numbers to letters. So numbers raised to variables. So again, I'm not changing the base, I'm changing the exponent. So I graphed y equals 2 to the x and y equals 3 to the x. Now, I know this graphs a parabola, but this doesn't graph a parabola. So I just made a t-table. Now you can use your calculator to graph it, but I want to show you what the calculator's doing. I just plugged in some x values to see what my y values came out to be. So if I let x be 0, 2 to the 0 is just 1. So I graphed the point 0, 1. So there it is right there. Then I substituted in a 1. So 2 to the 1, of course, is just 2. So I've got the point 1, 2. 1, 2. Then I put in a 2. So 2 to the second was 4. Then I put some negative numbers in there like a negative 1. 2 to the negative 1, remember, is the same thing as 1 over 2 to the positive 1. If you have a negative exponent, remember, you can move it from numerator to denominator and the sign of the exponent changes. So I get 1/2. So negative 1, 1/2. Then negative 2 was 1/4. So I get this kind of thing. Now I want you to notice something. Is this graph ever going to touch that x-axis? Think about it. Can you take 2 and put a question mark here? Is there anything that you can raise 2 and get a 0? Is 2 to any number going to be 0? No. And there's nothing you can raise 2. There's no power for 2 that'll make the answer negative. So that's why there's not any points down here. So this x-axis is really an asymptote. This curve's getting closer and closer to it, but it's never going to touch it. Now, what would happen instead of a 2 if you got a 3? All that happens is it looks just like this graph, but it gets a little steeper. When you plug in a 1, 3 to the 1 is 3. See, 2 to the 1 is 2. So it gets bigger faster. And again, it gets smaller quicker because, you know, 1/3 is smaller than 1/2. So the shape's the basic shape, but the bigger the base, the steeper it gets more quickly. Okay, so there's nothing fancy about numbers to letters. They're going to look like this. It's just this is either going to get steeper or it's going to get less steep. Now, the reason I'm showing you that, that's not really what I want to talk about. What I really want to talk about is this one. Okay, I want to talk about y equals e to the x. Now, most people panic when they see e. Okay, let me kind of do this for a second. Most people panic when they see an e. Well, e is an irrational number, just like pi. Pi is about approximately 3.14, a little more than 3. You know, it never ends, never repeats, doesn't terminate. Well, e is a different irrational number, and coincidentally, it's a little smaller than 3. So if you type in on your calculator e to the first power, you're going to get about 2.71 if you round it off. So all I did was make a t-table. If I take 2.71 and raise to the 0 power, I'd get 1 again. So 0, 1. If I took and raised 2.71 to the first, see, I'd get a number a little more than 2, but close to 3. So remember, this is y equals 2 to the x, and this equals y equals 3 to the x. Well, isn't 2.71 somewhere between 2 and 3? So my graph is somewhere between 2 to the x and 3 to the x, because 2.71 is between 2 and 3. So there's nothing magical about this graph. It's just like 2 to the x or 3 to the x. It's just your base is between 2 and 3, a little closer to 3. So you can make a t-table to get it. Okay, now I want you to notice something. They're going to ask you some questions about this graph. They're going to ask you the domain, the range, the x-intercept, the y-intercept. Is it 1 to 1? Is it a function? Now notice it is a function. Now, how do I know that it's a function? Remember, when it's a function, it's got to pass that vertical line test. No matter where you drew these vertical lines, you only cross the graph once. Now, is it a 1-to-1 function? Well, think about it. Now I've got to not only pass the vertical line test, I got to pass the horizontal line test. But again, if I went and drew horizontal lines, wouldn't they all just cross one point? So this is a 1-to-1 function. Now, domain, remember the x values. If you made a t-table, what kind of x values would give you numbers? Do you see that if I plugged in a 1, I get a point? If I plug in a 2, I get a point. If I plug in 0, I get a point. If I plug in the -1, I get a point. So my graph, the points have some negative x values, positive x values, 0. My domain's all real numbers. But remember, notice my range or my y values. I don't have any points down here below the x-axis. I don't get any negative y's. So that's why my range are positive numbers. Now remember that parenthesis means don't include 0. There's no point that's going to touch this x-axis. So do you have any x-intercepts? Does this thing ever cross the x-axis? No, so it doesn't have any x-intercepts, but it does cross the y-axis. So the y-intercept's the point 0, 1. So I expect you to be able to graph numbers raised to variables, but the one that you'll see the most often is going to be e to the x, this one, okay? Now, let's go talk about this real quick. Okay, let's see if I can get this to drop back down. Okay. Sometimes it wants to be temperamental. Okay. Now, let's go talk about logs first before we do the other graph. So let's kind of jump down here. A lot of people don't really understand what logs are. Now, you can write exponents as logs and logs as exponents. And most of you are probably more familiar with exponents. So if you have trouble with logs, change them to exponents. Now you can also use your calculator. Let me show you what I'm talking about. If I ask you for log of 1,000 with a base of 10, for most of y'all, that's just kind of Greek. So let's change it to its equivalent exponential problem because you think better. Here's what it's saying. Notice this b, when you're writing in exponents, becomes your base. So the base of your log is the base of your exponent. Notice that this answer is your exponent over here. So do you understand that the equivalent, this is my b, so what I'm saying is, I'm saying that 10 raised to some number gives me 1,000. So 10 raised to some number, so whatever this answer is my power over here. See, it's saying this thing raised to that power equals this. All right. So what do you have to raise 10 to get 1,000? Isn't that a cube, like a 3? So because this answer's 3, that means this answer's 3. So the log of 1,000 with the base of 10 is a 3. All right, what about a log of 8 with the base of 2? Well, again, change it to its equivalent exponential function. So 2 raised to something is 8. 2 raised to some power is 8. What's your power right there? Well, it's not 2 because 2 squared would be 4. Wouldn't it again be 3? 2 to the third is 8. So again, this answer over here is a 3. The log of 8 with the base of 2 is 3. Well, what about this one? Log of 16 with the base of 4. Well, remember, this is my base, that is my power. So that's how I knew to write 4 to the x, and this is your answer. So what power can you put with a 4 to get a 16? Isn't it a squared or a 2? So this answer right here would be a 2. Log of 16 with the base of 4 is a 2. So that's how you would do logs of different bases. Now, sometimes you don't get number answers. Like, think about it. What if I said log, okay, let's make that look a little more like an L, of base 10, all right, of like 40. All right, it's going to equal something. All right, so let's go back and make my 40. Look what I'm saying. I'm saying that 10 raised to some power would equal 40. Now, here's the problem. There's no integer that will work. Think about it. 10 to the first would be 10, right? What about 10 to the second? All right, 10 to the second power would be 100. So here's my problem. X, a 1 doesn't work because 10's too small. A 2 doesn't work because the answer is too big. See, I'm looking for 40. 40 is somewhere between 10 and 100. So here's what I do know. Then I know that this X is some number between 1 and 2. And it's going to be a little closer to 1 than it is to 2. Like 40 is almost halfway, but it's a little close to 10 than it is to 100. So that means this X is going to be some decimal approximation. You're not going to get an integer. If you type it on your calculator, what's the log of 40? You're going to get a number that's a little bit less probably than 1.5, because it's a little closer to 1 than it is to 2. Now, remember E is an irrational number. Okay, remember it's about 2.71. So when they have log of base of E of 1, they're saying E to some number is 1. 2.71 raised to what number is 1? Well, anything raised to the 0 power is 1. So that's how I know that this answer right here is 0. Now, here's what's true though. The bases that come up the most are 10. So if they just ask you for log of 1,000, when there's no base showing, it's understood to be 10. But even more common than base 10 is a base E. So much so that it has its own name. So instead of writing log with the base of E, they're going to put LN for natural log. But that's what LN means. LN means log with the base of E. So they're going to write number 4 on your test like this and on your homework. up there. They're going to say, what's the natural log of 1? Not what's the log of base e, but 4 right here and 4 right here are the same problem. All right, what if they say, what's the natural log of 8? Again, you've got your calculator, but do you understand that natural log means log with a base of e? So that means e raised to some power is going to give me 8. Well, like number 3 up here, I can't get an integer because remember, e is about 2.71. Well, if it's the first power, it'd be about 2.71. What if you squared it? Well, you'd get a little more than 7. If you cubed it, you're almost at 20, and I'm looking for an answer of 8. So 8 would be a lot closer to 7 3/10 rounded off than it would be to that. So that means that my answer is somewhere between 2 and 3, but it would be a lot closer to 2 than it is to 3. And if you take your calculator and type in the natural log of 8, look what you get. You do get a number between 2 and 3 that's a lot closer to 2. So for a test, I expect you to understand that natural log is log with a base of e. I expect you to be able to change logs to their equivalent exponential equation, but you could use your calculator to get the answers. Now, what if I went and I decided that I wanted to graph it? All right, I want to show you something about graphing logs, and the one I'm going to graph is natural log because it's the one that shows up the most. Okay, now let's see if it's here. Here it is. If you type in y equals natural log of x with your calculator, you get this graph. Okay, but let me show you where this graph comes from, like in a t-table. If I just type in my calculator the natural log of 1, it tells me 0. So the 0.10 is on that graph. If I type in a 2, the natural log of 2, if I rounded it off, I'd get about 0.7. So 2 didn't go quite up to 1. If I type in a 3, natural log of 3, I get a little more than 1. So when these numbers get bigger, the logs get bigger kind of slowly. That's why it curves that way. Now, if you type in the natural log of a half, it is almost a -1. If you type in the natural log of 1/10, it's almost a -2. Now, if you type in natural log of 0, or you type in the natural log of a negative number, you're going to get an error message. Because e to no number is 0, and e to no number is going to give you a negative number. So notice your domain here. Now my x values are never negative. All right. So now my domain are my positive numbers and my ranges are my real numbers. So I've got negative y's and 0 and positive y's. I've got an x-intercept this time, but no y-intercept on this graph. Now, what I want you to notice is this. Remember when we did the graph for e to the x? All right, I redid it. That's y equals e to the x. And then on the same picture, I graphed y equals the natural log of x. So I want you to notice the 0.10 is on this one, and the 0.01 is on that one. The domain of this one is the same thing as the range of that one. Remember? Think about it. Here, my range is all real number. My range is all real numbers. Here, my range are positive numbers. So what ends up happening is we find out that e to the x and the natural log of x are inverses to each other. See, this graph's also 1 to 1. Now, if you have the graphs on the same set of axes, it's real easy to see if they're inverses. If you have inverse graphs on the same picture and you draw the line y equals x and you fold along that line, inverses will always fit right on top of each other. So e and natural log are inverses of each other. So that means they would undo each other the same way that square and square root undo each other. The same way that adding 5 and subtracting 5 would undo each other. All right. So e to the x and the natural log of x, e and natural log are inverses of each other. All right. Now, what we're going to do next, we're going to talk about 3 rules that you need to memorize, and they're in your book, all right? But if you don't memorize them, you're going to give yourself an algebraic nightmare when we start doing something called derivatives, okay? So these are the 3 rules at the top of the page right here I need you to memorize. If you don't, you're going to make your life really miserable later, okay? Now look what it says. If you have, it works with any log, but you're going to see natural logs most often, so I put it in terms of natural logs because your book does. If you have the natural log of a product, remember there's an understood times there. It is not the natural log of the first one times the natural log of the second one. It's the natural log of the first one plus the natural log of the second one. Now, in order to convince you of that, here's what I would suggest that you do. All right. The natural log is 6. All right. Now, do we agree that 6 is 2 times 3? All right. 2 times 3. Let's make that a bigger dot. Well, according to the first rule, if you took the natural log of 2, okay, and you took the natural log of 3, and you found those 2 answers with your calculator and you added them, this answer should be exactly the same as just the natural log of 6. So what I want you to do is I want you to do that. I want you to take your calculator and get the natural log of 6. You'll get like a long decimal approximation. Then I want you to go do the natural log of 2 and the natural log of 3 and add those answers and just verify that this answer is the natural log of 6. So stop the video and do that for me. Okay, hopefully you did what I asked you to do. Okay, so what we got up here now is we know that you can change a product to a sum if you do it this way. Same thing on division. If you've got the natural log of A divided by B, it's not the natural log of A divided by the natural log of B, it's the natural log of the top one minus the natural log of that bottom denominator. If you have the natural log of something to a power, this tells you can pull that number in front and get the same answer. So that would be something like this. That might be useful sometime. And again, you can take your calculator and verify it if you need to. Do we agree that 8 is the same thing as 2 cubed? Remember, you found 2 a minute ago. Okay. Well, according to rule number 3, I can take that 3 and move it down front. So I can do 3 times the natural log of 2. So what I want you to do again, stop it and verify. Find the natural log of 8 and save that answer. Then find the natural log of 2 and triple it and see if those match. Okay, and they should. Now, what you're going to do is you're going to, for your homework, you're going to have to what they call expand and condense things. All right, using these rules. So expand, when things expand, remember they get bigger. So it's not that this answer's bigger than that answer, it's that the form is expanded, okay? So I'm going to use these 3 rules and expand as much as I can expand. So do you see that there's an understood times, x times y squared? So which one has a rule about multiplication? See, that's rule 1. So that's the natural log of the first thing. So the natural log of x plus the natural log of this second thing, y squared. Now, this part looks like rule number 3, which is I can take that power and move it down front. So that's what I took that power and moved it down front. And that's as expanded as I can get it. I don't have a rule about a number times anything. So that's as expanded as I can get it. All right, look at example 2. It says expand this one. Well, there are not any rules about roots, but remember, roots can get changed to powers. So I've got the natural log of something to a power. So look what this says. I can take that power and move it down front. So that's what I did. I took that power and moved it down front. So I had 1/2 times that natural log. Well, do you see that this is a division or a fraction? So now I use rule number 2. That's the natural log of the top minus the natural log of the bottom. Now, you cannot distribute that ln. That is not the natural log of x plus the natural log of 1. See, I don't have a rule about plus over here. So you're going to take these 3 rules and make things, their form bigger. You're going to expand them. Then some of your homework problems say condense. So instead of going left to right on the rule, if it says condense, you go from right to left. So what it's doing is giving you the expanded and want you to back up to the original problem. So if I had a power in front, I would know, well, if I saw this subtraction, I would know, well, with subtraction, I can write that as division. So that's what I would do. I'd back up and write this. Then I would go, okay, now I've got a number in front. Well, if I've got a number in front, I can back that number up and make it a power. So if they want you to expand, you use this rule left to right. If they want it condensed, you use it right to left. Okay? So what I want you to do now is you've watched the video, you can go back and pause it, rewatch anything you want to, and go try to work that homework. And then Tuesday, what I'll do is at 3 o'clock, you have to Zoom in for class. I'll answer homework questions. And by then, I'll have another video ready for you to watch. So this week that I'm in quarantine, what you're going to do is you're going to watch a video and try to do homework. And then you're going to come to Zoom class and get questions answered. Then you're going to go watch another video and do homework, and then come to this class on Zoom and get your questions answered. Now, if you decide that you're lost and need help, we can do one-on-one Zoom meetings. You just send me an email and we'll get together one-on-one. Okay? So hopefully y'all have a great week, and I'll see you in person in a week.